The Pythagoras theorem can be proved in many ways, and we have already seen one previously. Here, let's look at another way in which we can prove it. It's relatively easy. Let's draw a square with the length of all its sides equal to c units. Now we need to construct a triangle with side c as the hypotenuse. So we draw these two lines perpendicular to each other. This becomes a right triangle with this as the hypotenuse. Let the length of this side be a and that of this side be b. We need to prove that a squared plus b squared equals c squared. As this is a square, the length of this side will also be c. Now let's complete this right triangle. This length will be a units, this will be b units. In a similar way, let us complete this triangle. This will be a right triangle with sides a, b and c. Drawing this line gives us another right angle triangle with sides a, b and c. In each of the triangles, the side with length c is the hypotenuse. What we should be interested in finding is the area of the larger square. If you look at the figure carefully, you will notice that what we have in the middle is another square with lengths of sides a minus b. This length is a and this one is b, which is why this will be a minus b. In a similar way, each of the other sides of this quadrilateral will also be equal to a minus b. But what we are interested in finding is the area of the larger square. Zara and Zen were discussing about how they can find the area of the larger square. Zara says that the area of any square equals side multiplied by side. So she writes the area as c times c, which equals c squared. Zen does not use the formula, but instead thinks of a different way to find the area of this square. He says that the area of the larger square will equal the area of the 5 figures formed within the square, 4 of which are triangles and 1 square. So the area of the larger square will be equal to the area of the 4 triangles plus the area of the smaller square formed in the center. First, let's look at the triangles. Each of the triangles has their height as a units and their base as b units. So we can write the total area of the 4 triangles as 4 times half AB. But what is the area of the smaller square formed in the center? As the length of each of its sides is a minus b, its area will be a minus b the whole squared. All we need to do now is work this out. 4 times half AB will equal 2AB, and using the identity, we can write this as a squared minus 2ab plus b squared. 2ab and minus 2ab cancel out, and what we get on the right hand side is a squared plus b squared. We're talking about the area of the same square, so we can say c squared equals a squared plus b squared. So if we have a right triangle with sides a and b and hypotenuse c, then the Pythagoras theorem says that c squared will equal a squared plus b squared.